Does that make sense to y'all?
So what is that one called then?
It's an uncompensated respiratory acidosis.
So if it's uncompensated, that's when you can have the. I know the chart says normal for acidosis for the pH CO2, or for metabolic, and then it says normal for the bicarbonate for the respiratory. So if those numbers aren't normal, then it's uncompensated.
Right. If the pH is not back to normal, okay, if the pH is not back to 735 to 745, then it is uncompensated, okay? In order for it to be a compensated blood gas, the pH has to be 735 to 745, okay? In this case, we know that it's respiratory because pH is down and CO2 is up. Whenever it's opposite, it's respiratory, all right? And the bicarb is only saying it's trying to pull the pH higher to bring it normal, but it's just not got there yet. All right, so it's not compensated. It's not even partially compensated because the pH is 4 points below 735. Okay? All right, let's see. Who wants to do number 3? Raise a hand. Yes, sorry, go ahead.
For number 1, because the bicarb is normal, does that mean it's not compensated or uncompensated?
It's just a respiratory acidosis, and since the pH is below 735, it's not anywhere near normal. It's not compensated. Okay? We don't.
Okay, I understand that it's acidotic, and
Okay.
I understand that it's respiratory.
Mm-hmm.
If the bicarb is trying to arrange itself, it makes it completely normal pH, then it will be a complete compensated.
If the pH was back to 735, then it would be fully compensated.
And if it's not, it's uncompensated.
It's uncompensated,
But if
yes.
the bicarb is normal, does that still mean it's uncompensated?
It may have been, in this particular case, it may have been that the kidneys haven't had time to kick in to try and compensate.
So do we label it uncompensated then?
Yeah, it's still uncompensated.
Okay.
Yeah, I mean, the only time you really want to call it compensated is when the pH is back in normal range. And the other two are, they may be, I mean, the PCO2 may be back down in normal range too, but the bicarb's higher than normal, okay? That doesn't make it an alkalosis. It's still a respiratory acidosis because you're looking at trends, right? Not just one reading, all right? Y'all did get that from the last 2 weeks, right?
Yeah.
Okay? All right. Just want to make sure everybody remembers that. You got to look at more than one reading. So, you've been looking at this trend, and they've been in respiratory acidosis, and all of a sudden, finally, the bicarb starts to rise. Okay? And then, as soon as it rises, the pH goes to normal. That rise in bicarbonate is what compensated it to normal pH. And that's the only time you should really consider it to be a fully compensated issue. Otherwise, it's uncompensated. All right. Amy, you want to do number 3?
Okay, it's acidotic.
Okay, the pH is 731. All right.
The CO2 is within normal limits.
Okay.
And the bicarb is low.
All right.
So uncompensated metabolic acidosis.
Okay, it's a metabolic acidosis. Now, how do we know that? Do your arrows.
Because the pH is down and the bicarb is down.
Right, because both of those are going down. And the other part of it is that CO2 is normal.
Yes.
Okay. Now, what would you say it was if the PCO2 was 30?
You would say mixed acid-base problem.
All right, well, that's right. In a way, that is exactly what's happening. Okay, but what made it mix? The PCO2 started to drop. Remember, we said if the pH is low, we can a respiratory system can compensate one of 2 ways. It can either retain CO2 or it can blow it off. Okay, so what happened was this guy started doing what? Hyperventilating. He blew off his CO2, but did it do anything to the bicarb, the pH? No, it didn't. All right, because the problem is the CO2 is not going to be able to fix it because it's the bicarbonate that's wrong.
Okay.
Okay? That's because it's metabolic. Respiratory is going to try and compensate it, but the PCO2 can only go so low. You can only breathe so fast before you wear out.
So then what would you call it?
Well, in this case, what it's trying to do, it's a metabolic acidosis, all right? And the respiratory system is trying to start compensating, but it's not successful at this point. All right, now, this is a loaded question, and there's a lot of debate on this, but would you want to give somebody like this bicarbonate? All right, Mary, why would that be? Was that you that said that, Mary? All right, why would you not want to give them bicarbonate?
For one, it's pretty close to normal. It's only 2
Well, yeah,
And you can see if they're gonna start compensating.
okay. All right, so you want to give them a little bit of time,
Yeah.
and that's an
because
excellent decision, okay?
It's not that far off.
Right. It's not way far off, but you do need to give them some time and see what's going to happen. Yes.
I was just gonna say until the kidneys kick in.
Right, until, well, I mean, it's a metabolic problem, so the kidneys aren't necessarily going to kick in. They're what's causing the problem to begin with. Okay.
Test them again.
Yeah, I go back in a couple hours, put them on oxygen, make sure that their oxygenation is okay. But I would be really hesitant to give them bicarb. We really don't want to give people bicarb until the pH is down in the 7.27, 7.28 range. Because if it gets much below that, it's inconsistent with life. Okay? All right. Same thing. And the other thing is that bicarb is not a solid science on its administration. There's no way that you can be precise in administering a bolus of, a Bristol jet of sodium bicarbonate. Because it's going to derange all your electrolytes, and it could make a metabolic acidosis actually go worse before it gets better. All right?
Isn't it dangerous enough people do sodium bicarb for
Yes, it is. People with kidney problems do not need to be doing sodium bicarbonate because it will alkalinize their body, and they can do it so bad that it'll kill them. Okay? If their pH gets too much over 7.5, that's also incompatible with life. Now, we're talking, like 7.56, 7.57, that kind of stuff. It has to get way up there. That's baking soda, yeah. I know. But see, this is, okay, and I don't disagree with you. A lot of people do use sodium bicarbonate. But again, in a renal patient, they must be taught, y'all getting that one? Renal patients, you have got to teach them not to use bicarbonate of soda because it will kill them, okay? And you cannot give, okay, and this is how I always teach people this, okay? How do you treat over sodium bicarbonemia, okay? That's a John word, okay? If you got too much alkaline in your body, how do you make it more acidic? Huh? No. All right. Do you think it's reasonable that we could give them a shot of hydrochloric acid and make them acidic?
No.
Actually, believe it or not, we used to. All right.
Lower the breathing rate too?
Well, you can lower the breathing rate. All right. Increase their oxygen level and decrease their breathing rate and make them retain CO2. But 25 years ago, we used to give very dilute hydrochloric acid infusions. Okay? Like 1 or 2 cc's of hydrochloric acid in 1,000 cc's of water. Okay? Not joking, I did this. I also gave alcohol treatments. All right? Where you put some pure ethanol in a respiratory thing and have them go. Right? It saponifies. Okay? Remember what soaping reactions were? It cuts the surface tension of water. So if you're drowning in pulmonary edema and you suck on an alcohol treatment, it cuts the foam. Okay? And it helps breathe easier. And it still works. I've still seen it done as recently as 2005 at a charity hospital in Louisiana. But anyway, go.